Hello, everybody. Hi,
Hello,
Eduardo.
everybody.
Okay, we will start in a little bit. Can you guys hear me properly? Okay, cool. Hi, Akib. Sorry, Ayub. I misread your name. I'm really sorry. Hi, Ayub. Good to see you too. Hi, Parsi. Hi, Tham. Yeah, there may be a little delay in this thing, but let's hope things go well. There is sometimes a little 5 second delay or so. Hello. So let's wait for another 2 minutes, and then we will start. Hi, Navia. Hi, Luciano. Hi, Shika. Good to see you all. Hi, Andy, Sachin. Hello, Sachin. Okay, so there are about 89 people online. I guess this is a good time to start now. 89 people are, it's a crowd. Um, okay, so let's get started. Let me share my screen with you guys. Are you guys able to see me? Hi, Sandeep. Okay, let's get started, guys. So, welcome to join the AI revolution with computer vision for faces. Now, we are going to have a great discussion here. Let me first assure you that you are in the right place. So if you are a programmer, if you are a student, an entrepreneur, or a hobbyist who is interested in AI and computer vision, you're in the right place. You may not know, you may not know enough about computer vision, AI, etc. But if you're interested, then you're in the right place, because we are going to learn today how AI is transforming the world. And we are going to learn how this course, Computer Vision for Faces, is going to help you take the first steps. So I think of everybody, including myself, as being on this growth path. We are this little seedling. We are a little plant that is growing in this sunshine of AI. It's going to be very interesting how the next few years are going to play out. Now, I would request you to stay till the end. I have a little gift for you, for anybody who stays till the end. And let me show you what it is. So basically, I'm a nerd. For me, a gift is code. So when I want to show some good gift, then I show you code. So if you stick around till the end of this webinar, you will receive this code for principal component analysis on faces. It's also called eigenfaces. What we have done here is we have taken many images of faces, and we have created the principal components. What are principal components? Principal components are nothing but directions along which these faces have maximum variability. Now, when you read about it, you don't get that sense of what these things are. But once you start visualizing them, it becomes very interesting. So here, we have the mean face on the left, and we have the generated face on the right. And we are changing the weights on the principal component. And we are trying to find what this means. What does the first principal component do? Well, the first principal component captures the background. Because if you take all the faces that were used in creating this image, it is the background that was variable the most. So it captures the maximum variability. So that's the background change. Now let's look at the second principal component. Amazing. So it is a combination of hair and skin tone. You can see that the hair comes back on the person, and the skin tone also darkens just a tiny bit. Let's look at the third principal component. Well, it's about lighting. It captures the lighting variation on the face, on one side, not the other side. And similarly, the fourth one captures some variation of the hair. So this is a fun piece of code that we wrote for people who will stick around. It's a Python code, and I'll be happy to share at the end of this webinar. So let's go back to our presentation. So now, people who do not know me, some of the people who are on this right now, they may not know me. Just a quick introduction. I am Satya Malik. I'm an entrepreneur in computer vision, machine learning, and AI. And I was also voted as one of the top 30 AI influencers to follow on Twitter by IBM's AI blog. Some of my work has been featured on BBC, IBM, TechCrunch, Time Magazine, Huffington Post, Register UK, etc. So let's just move on. Now we know each other. Now, one thing I want to emphasize is that everybody struggles in the beginning. And that was true about me as well. And this field of AI is growing at such a fast pace that you're always learning and you're always struggling. So if you're a beginner and you're struggling, don't worry too much about it. That is completely normal. Now, when I started in this niche area in computer vision called deep learning. I was new, I had read the theory, but I had not understood how to apply it in practice. And in one of my consulting projects, I was asked, to submit a proposal to do a particular problem, and I thought that deep learning would solve it, and I said so. It turned out that deep learning was a very good tool for it, except that I did not know how to use it. So that one day I struggled so much. I installed Caffe on my laptop. I understood how to use it. And then finally I couldn't do it. I had to take help from my friend. And all he had to change in my architecture was one little parameter. And boom, it started working. So my point is that everybody struggles in the beginning. And if you are struggling right now, that is nothing new. So I finally landed the contract. It was a very large contract of about $60,000, but at that time I did not know much. I learned through the process. I learned through my struggles, and that may be true about you as well. You may be struggling right now, but invest in yourself, and you will see that these things become easy as time progresses. Okay, now one of the things that has become mainstream, this idea has become mainstream, that AI is the new electricity. Now, what does that mean? What does it mean that something is like electricity? Well, the thing is that when electricity became mainstream about 100 years back, it first transformed lighting. People had lights in their homes. But then it went on to transform multiple industries. So it went to agriculture. Agriculture was transformed. It went into manufacturing. Manufacturing was transformed. It was a big revolution. Now, the same thing is true about AI also. It's not going to transform one industry. It is going to transform multiple industries. It is going to transform transportation, as you know, with Google Car. It's going to transform medicine and diagnostics. It is going to transform video surveillance, you name it, manufacturing, agriculture, financial tech, which is already under, it's making big leaps in that area. And it would be very difficult to think about one major industry that AI is not going to transform. So we are in the middle of this massive revolution. It's a really massive revolution. Now, when you're a beginner in artificial intelligence, in any field actually, there are terms people throw around, and we don't always understand what these things mean. Now, for example, what is the difference between AI and machine learning? Well, AI is this concept that you want people, you want machines to think like people and do like people, act like people, learn like people. So that's the concept. It is silent on how to achieve it. If you want to apply some logic, you're making a chess game and you want to apply some if then else logic, that is also AI, except that it's not very smart AI. So in case of machine learning, they said that the solution to this is not these if then else statements. The solution is data. So if you give enough data, we will be able to figure out how to solve a problem, right? So that is machine learning, solving AI problems using massive amount of data. Deep learning is a subset of machine learning. And in deep learning, what people do is they try to, they use neural networks to solve the problem. So it's a subset of machine learning, but neural networks are used. And the word deep refers to the fact that there are multiple hidden layers. So we have the input and the output layer. And if you have more than one hidden layer between the input and the output layer of the neural network, it is called deep learning. Now, computer vision is obviously when you want to understand information, when you want to extract information from images, that is computer vision. And computer vision doesn't exactly come under AI completely. It has a huge overlap with AI, but it has a lot of things that are outside AI. For example, when we build panoramas, we don't call that AI because it's a geometric problem that you can solve with zero data. you know how the images are related. You can stitch them together and create a panorama. On the other hand, you have things like image classification, where it is not just AI, it is also machine learning. And in particular, deep learning solves the image classification problem really, really well. Okay, now AI jobs are taking off. It's amazing. It's incredible. In my consulting work, I have never had to go and advertise or ask for work. People come to me uh, and give me work, and the reason is that AI is just exploding. There is so much demand for AI. There is a lot of demand for AI, and there are not enough skilled people. So you can see that between 2013 and 2018, there is going to be a 5x change in demand of jobs requiring AI skills. That's huge. That's, I mean, I just cannot explain how big this transformation is. Now, so what are people doing? Of course, people are enrolling in different courses for AI-related courses. So AI, machine learning kind of courses. And if you look at the enrollment in Stanford alone, you can see that enrollment went from almost near zero, a few hundred or maybe 100 enrollments, to nearly 1,500 this year. So it's an obvious response. When people see a lot of demand, they want to jump in. They want to contribute to the revolution. They want to benefit from the revolution. So if you are thinking about taking courses, that's a perfectly good thing to think about. It's a very smart thing to think about. Things are taking off. Jump on this great opportunity and make the best out of it. Now, artificial intelligence has three big components. So when somebody says they are working in AI, it may not be, you have to ask what branch of AI are you in? So one of the branches is computer vision. We take images and videos, and from that extract information. The second one is speech. Would be another example. The third one is natural language, which is essentially text data that you gather from the internet or other places, and you try to figure out. So suppose you're typing some text, and it wants to predict what the next word would be. That would come under natural language processing. Three big areas in artificial intelligence. Now, our focus is on computer vision. Teach in our blog as well as in the courses. It's very important. The reason is that 30% of all of our brain actually is dedicated to visual processing, and compare that with 8% for touch and 3% for hearing. If you ask my wife, she thinks that my hearing percentage is even lower. But you see, so visual data is very crucial for humans. We consume visual data primarily. Now, cameras are everywhere these days. One second. Hello? Hello? Are you guys able to see me? Hello? Okay. I thought, okay, great. Sorry about that. Okay, let's start again. Okay, so basically cameras are everywhere these days. Cameras are everywhere. So even when you start like with a baby, we put a camera next to a baby so that we can monitor whether they are well or not when you're not around. So it starts when you're a baby, and then you have cell phones which all have cameras now. Your laptops have cameras, your cars have cameras now, and cameras are looking at you all the time using surveillance cameras. And now drones are going to be huge also, and they too will carry cameras. And so we will have all this visual data coming in, which is going to be huge. Now, think about it. When you talk about natural language processing, text processing, in that case, humans have to create that data. So when you type something, you create that data. In case of speech recognition, again, humans have to create that data. In case of visual data, nobody needs to create any data. You just put a sensor there, and a lot of data comes in. So that's very, very powerful, very, very powerful. It has very wide applicability. For example, in agriculture, when you want to look at harvest, etc., you know that it is computer vision and not natural language processing that will be used. In manufacturing, it is the same thing. So compared to other branches of AI, I believe that computer vision would have a much larger share of things we can do. Now, one of the questions we have is, why do we learn face processing? So we teach computer vision for faces. What's so special about faces? Now, the very first thing is that faces are everywhere. If you think about photography itself, it was almost invented to capture people. So we want to capture people, and 80% of the images on the internet, or even more, are probably human faces. That's what people care about. And that's why when computer vision algorithms started, there was a lot of emphasis on face processing. The first object detector that actually worked in real world was a face detector. That was one of the big success of computer vision for a very long time. So we worked on face detection, face tracking, etc. And so it is it is historically, computer vision has been informed by faces. A lot of work has gone into face processing algorithms, and then you diversify from there into other areas. And face processing is, when you learn about face processing, it is so much more than just faces. For example, you have this bubble in the middle, face processing. But while learning face processing, you also learn about image recognition. You learn about face recognition. You learn about regression problems like landmark detection. You learn about objecting. And this is something we teach in the course as well. Not only that, face processing involves a lot of augmented reality. If you think about Snapchat filters, it's nothing but augmented reality. So in augmented reality, you have a video feed that is augmented in various ways to actually create a new reality, right? So the video, in case of a Snapchat filter, gets changed, and that is also under face processing. Now we also have emotion recognition. Earlier, we used to think that emotion recognition is this gimmicky thing. You do something and it's funny, but now it's big. Apple acquired a company called Emotion a few years back, just to do emotion recognition. And now you can see how Apple is moving into faces in a very big way. Advertisers use emotion recognition, and it's a very important field now. The same thing is about very basic things like image processing are also involved. I mean, you learn image processing also while learning face processing. Some of the basic stuff needs to be learned. Similarly, computational photography is something that you learn when you do face processing. Now, computational photography is kind of like augmented reality. You change the entire image you make images that a camera cannot make. So if you take multiple images of a person and create a new image that a camera cannot have produced, that's computational photography. We also will learn about object detection. So you can see that face processing, even though we say that, okay, it is just for faces, it has very wide applicability. It's actually pretty wide. Now, it is also becoming mainstream. Face processing is becoming mainstream. If you look at iPhone 10 features, the center of security is Face ID. So they have moved from fingerprint to faces. Whether or not you like it, whether or not you think that it was a good idea, the fact that a company as big as Apple has put their future, they're betting that faces are the right mode for authentication, right? It tells us a lot about how important face processing is going to be. And not only that, iOS 11 also has a facial landmark detector already built into it. Think about all the different features that they could have implemented, but they decided to use facial landmark detector. It may look like a small feature, but it has wide applicability, and that's why they decided to use put it right in the OS. It's fascinating. Now, not only that, look at all the cameras. All the cameras have a face detector. They in fact use the face to change exposure and focus the image as well. There is a huge application area in apps, in mobile apps. So if you think about Snapchat, if you think about Masquerade, Facetune, all these apps, they are, some of these are hundreds of millions of dollar companies. Snapchat is several billion-dollar companies, and the center of this thing is basically human faces, right? Their core application is very, very, very face-centered. Not only that, face processing is very important for security. Like we mentioned, face recognition is huge. Sometimes you do face verification. You don't recognize a person from a very large database. You just need to verify or authenticate them. It's also very important in advertising. So a lot of companies, when you upload a picture of your own face onto their website, they are able to tell what your skin tone is, what your eye color is, what your lip color is, etc. And based on your face, you can get targeted advertisement. And also in the beauty and fashion industry, faces have a huge effect. Some of my clientele is also in the automotive sector. So Tesla, for example, recently released a camera which is facing the driver. So now you can do drowsiness detection. You can see how the driver is behaving. And these tools can be used by insurance companies as well. So if you're a good driver and your the front-facing camera tells that, okay, this guy is a good driver, then you may get a discount. So the application area for face processing is huge. And we already talked about augmented reality. Snapchat filters, etc., is just the beginning. When you go full augmented reality, with head-mounted displays, then faces are going to still be the center of a lot of attention. Now, let me tell you a little bit about our course, Computer Vision for Faces, because that's the thing that we are currently offering. It's open for enrollment until the end of today, and we cover a lot of things from the very basic to the very advanced. So we start with installation. We will help you install this thing if you are stuck. And in some cases, we got on a Skype call with people to help them install this, because we really want to support this course. We want to support people who want to get into computer vision and machine learning. So it really is important that we provide exceptional support in the course. We start with the basics of OpenCV. We teach you, read, write images, read, write videos, etc. But then we move to slightly advanced topics like image filtering and image warping. But by the time we do this, you start to get a sense of what computer vision is, how to transform pixels, how to work with pixels, and you feel really good about how to use computer vision in your own application. And then we, sorry, then we move on to Instagram filters. Now, you'll be surprised how many different filters can be implemented by knowing just a few little tricks. We think about them as very different filters, but at the core, they are manipulation of some curves sometimes, they are manipulation of some standard algorithms sometimes. And we kinds of filters, sometimes it is curve manipulation, sometimes we do bilateral filtering. There are other kinds of edge preserving filtering that we talk about in the course as well. We talk a lot about facial landmark detector, and you can see why. We did this before iOS 11 decided to have facial landmark detector in their phone. And the reason is that we knew that facial landmark detection is going to be huge. So people who had enrolled in the previous version of the course and people who learn through our blog, they already know that I've been talking about landmark detection and related applications for almost 1.5 years now. You can see how some of these technologies have matured, and it is the right time for them to be in consumer applications. So when we talk about facial landmark detection in the course, we just don't talk about how to use it. We also talk about how to train your own facial landmark detector from scratch. So suppose you're building a mobile application, you don't want to put a 100 megabyte file, model file. You want to have a 30 megabyte, maybe 15 megabyte model file. How do you use a fewer number of images? How do you train your own model? So those things we teach in the course. We also teach the theory of facial landmark detection, but if you're not very mathematically inclined, you can skip the theory and still get the complete benefit of how to use it, how to train it, and how to use it in your application. So it's when we talk about facial landmark detection in the blog or in our free courses, we talk about applications, but here we talk about how to get into the bottom of the things, how to train, as well as how to use the application in a very integrated way. So it's a much smoother experience in the paid course. Now, some of you may have even seen these applications like face averaging. In the course, we integrate everything with dlib nicely. You don't have to write it to the file, etc. And you understand the material is also much smoother. We have refined it much more for the course. You will learn about face morphing, and this is not a political statement. It is just an example of face morphing. We will teach you how to morph a human with a tiger. We will also teach how to do face swap in images and videos. With images, you have the luxury of using a heavy-duty algorithm. So one of the things that you will learn in the course is how different algorithms make sense for different kinds of for different kinds of people, or for different kinds of applications. For example, when you're dealing with images, you can go with high-quality, slow algorithms. But in case of videos, you cannot go slow. It has to be a fast algorithm, even though the quality is slightly lower. So you make these choices, and that's what a practical application looks like. That's what practical learning is. You make those choices, and you have information about both choices to use it. So we'll also learn about Snapchat filters. And even though we call it Snapchat filters, it's for fun. What we are learning about is how to use alpha blending, how to use image transforms, how to use nonlinear image transforms, etc. So the underlying math, I'm simplifying it so that it's more accessible. You know that, oh, we are building a Snapchat filter, but there is complexity inside, and we will learn how that happens, right? How do you put a mustache? You can do that in Photoshop, but how do you do that in code? And how do you make the ends, the seams not stand out? How do they blend properly? We will talk about blink and drowsiness detection. There are many ways to do it. For example, one way would be to actually detect facial landmarks and then detect the landmarks around the eyes, and then use those landmarks to say whether the eyes are closed or open. But that's not the only way. You can actually use an image classification technique to solve the same problem. So when you take this course, we we try to talk about different approaches to solve the exact same problem, right? There is no single approach for all kinds of problems. There is no single approach. You have different choices, and the choices make sense under different circumstances. So, for example, in case of blink detection, you can use support vector machines and HOG, the the feature detector or feature descriptor called HOG, to do this thing as well. Or you could use facial landmark detector. And the choice you make, it depends, which choice you make. Sometimes in a mobile application, you do not have the luxury of carrying this big model, the landmark model, into the application. In that case, it may make sense to just use support vector machine and with HOG descriptor. We'll talk about these kinds of choices in the in the course. We also talk about skin detection. Again, these are about choices. Now, we can use a heavy-duty, very accurate skin detector when we are working with images. But when we are working with videos, we have to use something quick and dirty. It may not be very accurate, but it has to work in real time. We can also sometimes make use of additional information. It is not just the color information that informs what is skin and what is not. We can use the fact that it is a face to more accurately produce the skin region. So those are the kinds of things that when you take a course, when you take a practical course, you get exposed to, right? Otherwise, you read about skin detection. Oh, I learned a skin detection algorithm, but when it comes time to apply it to real world, it doesn't work at all because it's the wrong algorithm for that particular application. In addition, we also have this fun application called blemish removal. So the application looks simple, right? It's called blemish removal, and you remove blemishes. However, under this thing, there is some sophisticated algorithm going on there. For example, in this particular case, we use a GraphCut-based algorithm called GrabCut to replace regions on the face. And the region is chosen using some similarity metric. So again, those kinds of things, they're complex, but once you have this nice application, those complexities are removed, and we get this very nice application that we can show to our friends, and they will understand what we are doing. So it's unlike other fields in electrical engineering or something, where you cannot tell your friends what you do. Here you can show your friends, look, this is what I did. Isn't that cool? We will also learn about object detection and tracking. And like I was saying, that there are different methods for different applications. So we will learn two different object detection algorithms. One is based on HAR features, which you use for faces. And then there are HOG feature-based object detectors that you use for pedestrians and other, there are other applications where a HOG-based object detector makes more sense. Similarly, we will learn about tracking, object tracking. The difference between detection and tracking is that in case of you have prior information, it's done on a video. So you have detected the object, and now you want to see how it moves from frame to frame. Because you have this additional information, you should be able to do a better job than object detection. So object detection is good at detecting the object, but it is bad at localizing the object. So you don't know, an approximate location where it is located, but you don't know the precise location. So tracking is very good at precisely locating, but can also go off track. So sometimes you're tracking something and drift off. So you use a combination of object detection and tracking. So you detect the object, let it track, because tracking is also usually less expensive. So you let the object be tracked in the video for a few frames, and then you detect again. And for detection and track, also cover things like Kalman filtering, which was actually used to track in World War II, the location of missiles. So this is like rocket science. Okay, a lot of you may have this question that are we going to cover deep learning in this course? And because deep learning is a very important field, yes, we do cover deep learning, and we provide you an introduction to deep learning using TensorFlow. So we will be able to solve a few problems using deep learning. So modules out of 11 or 12 modules are deep learning based. So you get your hands dirty deep learning. But I also want to emphasize that this is not a deep learning only course. Most of the algorithms that we learn will use something other than deep learning. 3 of the modules will use deep learning. And we'll use deep learning for face recognition also. But in addition, we will also show 2 other traditional methods. So sometimes you don't recognize how well some algorithms work as you see traditional methods. And sometimes the traditional methods make sense based on the application you're trying to build. They are easier to deploy, and there are other considerations because of which you may actually want to go with a traditional method. We talk about that in the course as well. Emotion recognition. Emotion recognition is extremely hard. It is, and if you use traditional methods, they don't work very well. So we do show in the course how you can use DLib's landmark detector to do emotion recognition. And then we also how much superior results you can get when you use deep learning based methods for emotion recognition. Now there are 3 variations of the course. With full access, you get access to the course forum. We are very active on the forum, and you can join anytime. You can ask questions. People will also answer your questions. With Full Access Plus, we have this additional live QA. So every 2 weeks, we have this live QA session. In addition, we will also share code, a starter code for facial landmark detection on iOS. If you're using iOS 10, or then we will use a DLib's integration. We will show how to integrate DLib with your application. If you're using iOS 11, in that case, we will show an example of native application. Prerequisites for the course, you need to know either C++ or Python. You don't really need to know both the languages, but if you're interested in one of the languages and have just little interest in the other language, this is a good course because we provide code. For most of the modules, we provide code where you can have C++ and Python code, and you can compare them and see how something is done in C++ versus in Python. Python is a great prototyping language, but when you want to build high-performance applications, then you have to use C++. For example, in embedded devices and such, you have to go down to a C++ and cut it sometimes. We also have a 30-day money-back guarantee with the course, no questions asked. We remind you at least 3 times that the refund is coming, the refund deadline is coming. Please go and take a refund if you don't like the course. And out of the 429 people who registered for the course last time, only 12 had asked for a refund, and that too for several personal reasons. So if you're thinking about the course, are not sure, just take the course and get a refund if you don't like it. There will be no hard feelings. We know that people have different priorities, and it's not always to go through with a course. So that is something really nice that we are able to provide. certificate of completion. Once you complete the course, you get a certificate of completion. But what does it mean to complete the course? We have quizzes and assignments inside the course. The quizzes are auto-graded. The assignments are not graded. When you show us the assignment in the forums, you get bragging rights. People like what you have done, and they ask you questions. So, but we don't grade your assignments. What we grade is the final project. So the big thing in the course is the final project. And the final project carries a prize. So there is $1,000 prize. So we split it into, the first person gets $500, the second one $300, and the third prize is $200. And it's like a competition. You work on it for a month, but really you spend about 40 hours total on it, and come up with something that you have thought about, some application that is your baby, right? It's not something we say, oh, solve this. No, it is something that you have creatively thought about. So the question is yours and the solution is yours. Now the competition is about how creative the question was and how creative the solution was, how well it works. So that's the best project award. But even if you don't win the best project award, you get this completion certificate. You get this completion certificate. There are no deadlines. If you don't want to participate in the best project award, then there are no deadlines. You can get a certificate even in a year, right? So you have about a year to complete the whole course. Okay, now I have a bonus for all the people who are on the webinar. If you decide to buy the course in the next 30 minutes, we will add a new module to your offering. We will provide code for doing panoramas and image alignment. Of course, it has nothing to do with faces, but this is an additional module that you will get access to. And if you have already bought the course, don't worry about it. We will add this module to your course as well. So anybody who has bought the course already, they will get this, and anybody who buys the course in the next 30 minutes, they can get access to this as well. Now, the URL of the course is courses.learnopenCV.com/p/computer-vision-for-faces. And Vikas will share the URL in the list. So we can open ourselves for questions now while this timer runs. So let me stop sharing this. Okay, so let's see what questions people have. No, the full course content will not be available for the first 30 days. The course is released in week by week. Week you get access to the content. So by the fourth week, you will get access to 4 weeks worth of content. One of the questions is it going to be useful for beginners? Yes, our goal was to create a course that you do not require any prerequisite in image processing, computer vision, machine learning, but you do need to have an intermediate knowledge of C++ or Python. If you do not have knowledge of either of these two languages, I would recommend that you do not take the course. We can actually give out the link, the principal component analysis code that we had promised, so people can Thanks, Code Gusto. Thanks, Munesh. One of the questions is, will we design our own architecture? The answer is that we will provide you, and I'm assuming that this is a deep learning question. In deep learning, we will provide you with an architecture, and of course, you feel free to change the architecture and try to see how it improves the results. But so that's up to you. In an assignment, if you beat what we have already done, that's great. And a lot of deep learning is actually trial and error. Like if you even ask anybody, like top experts in the field, they do a lot of trial and error. So the architecture is based on what already works for people. So you start with that and try to modify and bring up your own solution. Oh yeah, so there are big advantages of using the GPU. Not only in deep learning. In deep learning, it's almost required. You pretty much cannot do anything if you do not use a GPU. So like the training will take a long time, and the detection will take a long time as well. Inference will take a long time as well. But if it is just a classification problem, maybe it will take 200 or 300 milliseconds, or even less, maybe 100 milliseconds. But it's always good to have a GPU. In all the other things that we teach, GPU is a good to have, but it's not a necessity. And in OpenCV, there is a very easy way to enable GPU without changing much of the code. In our course, we do not explicitly teach how to use the GPU, but it's relatively simple. So the total cost of the course is $300, and we also provide a payment plan. You can have a 3 installment plan of $109 each. Yes, Munesh, yeah, TensorFlow is discussed. We give an introduction to TensorFlow. We show you an example how to solve a classification problem. So you get an introduction to TensorFlow, and also emotion recognition, for example, is implemented in TensorFlow. So you will get that as well. Nasrul asks, what is the best way to develop OpenCV app for Android? So OpenCV apps for Android, you actually use C++. So you first develop everything on your desktop using C++, and then you transfer it onto Android, and then you communicate with the Android app using JNIs. So Java Native Library. You can also use the Java version of OpenCV, but when we have used for some clients, we found that the JNI option is very good. Usually we work on the C++ side. We just hand them the code, and they use JNIs to do the integration. Thanks, Ricardo. If you have experience with deep learning, the deep learning, if you have already experience with deep learning, taking this course for deep learning doesn't make sense. This the level we go in deep learning is kind of introductory. We show 3 applications, but that's about it. But there are so many other things that are beyond deep learning. So like I showed in that graph, deep learning is a small class of algorithms. There are so many algorithms beyond deep learning that this course teaches. And deep learning does very well on those classes of problems. For example, object detection, image classification, etc. It is the best thing available out there. But there are a lot of things that it doesn't make sense to use deep learning. It's not even clear how to use deep learning in some of these things. And in some cases, you can have faster applications when you don't use deep learning in some cases. So it's a choice. But don't take this course if you already know deep learning and want to learn more about deep learning. Take this course if you want to learn about other aspects of computer vision, right? In addition to deep learning. So Sai asks, do you provide the material? So all the material in the course, you can download it. They are as PDFs. The videos also, you can download it so that you can consume them easily. Yeah, so all the material is available, and they will be available forever. When we launch this course, it is you have access to it for life. The support will end after some time, but the access to the material is forever. So Munesh asks, what is the right learning step after this course? There are various things that you can learn in. So this course will give you a very good understanding, very solid understanding of various things available in computer vision. It is not just about faces, it's much more than faces. So you will have a very broad background. Now, if you want to dig deeper into certain areas, like you want to dig deeper into deep learning, then you can go and take a deep learning course as well. You want to dig deep into, say, 3D, not 3D reconstruction, but say AR, artificial augmented reality. In that case, you can go explore those courses as well. So it actually, what you should do is, after you take this course, you will have an understanding of what area excites you. So what area makes you really, go, I want to do this, and try and explore that in greater depth. That would be my advice. So for face swapping, one question is there any extra information apart from the one that we have shared in the blog? Yes. So most of the material that that is sometimes common, we go into greater depth. So for example, in case of face swapping, we provide a video implementation. The face swap example in the blog will work only for images because that was the choice we made. But for videos, it will be very slow. So in that case, you will have to use a different stitching algorithm. So one of the questions is how to make very secure door security system with webcam and image recognition, how to detect live image. So that's a long question, but so face recognition, even the one we teach in the course, is pretty industrial grade. You can get very high accuracy with that face detector. The problem is liveness detection. So the problem that you run into is liveness detection. How do you know that it is not this person's photograph? And that is a very difficult problem. I cannot explain those things here. That's why you have dedicated hardware in iOS, in Apple phone, just to do that reliably. Face recognition using OpenCV is okay. You cannot use that in commercial applications. It's not that good quality. Face recognition using DLib is pretty good. You can actually you can make it even better if you train from scratch. But the one in DLib, you can actually use it to do reasonable applications. But then again, I said that the main problem in face recognition is liveness right now. And to do liveness really reliably, you need additional hardware, just like Apple is doing. Yeah, so Nazrul, we actually show how to use DLib in OpenCV OpenCV projects. So many of our examples use DLib and OpenCV in the same application. And we also show how to efficiently transform one image format to other so that there is no memory swapping going on or memory copy going on. So Sandeep asks, is in deep learning course there is CNN? Yeah. So because we use images, most of the things are convolutional neural networks. We also show a simple neural network where it's not a convolutional neural network, but for images, it is always CNN. Guest 9003 asks, will the algorithm develop work for human face separated across age regression? If you have trained it across ages, then it will work. If you have not trained it, it will not work. So because there is substantial difference between, say, a baby, when you were a baby and when you are an adult, is not going face recognition is not going to work. But if you have trained the entire, the progression, then it will be able to detect that it is the same person. So tracking, we actually there are multiple tracking algorithms that we share. Some of it is in that repository that you're probably referring to. I cannot see it right now, but we do cover. So tracking also involves many things. So we show how to do tracking using Kalman filtering, for example, which usually you don't find in many courses. We also show OpenCV's tracking algorithms, how to use multiple object tracker, how to use object detector plus tracking in conjunction. And there are also tracking of points. So one of the codes that you see is stabilization of facial landmarks. Now, stabilization of the facial landmarks involves tracking the points, because if you just use dlib's facial landmark, you will see that they jiggle a lot. So in the code, we show how to track points or features and how to reliably track them, what to do when the tracking fails. So you can, that's another kind of tracking. Yeah, so we have feature tracking as well as object tracking. So SWORD is another algorithm that the deep learning folks use for tracking. But in case, yes, it does use Kalman filtering for sure. But in traditional computer vision things, you don't have bounding boxes. When you say tracking, you actually you track the object. You don't have a bounding box that you connect. In case of SWORD, you actually have all the bounding boxes and in every frame. If you could not detect a bounding box, then SWORD will fail. But in case of traditional techniques, you detect, you track in every frame. You also take the pixel values into consideration. Have we shared already? We should share the code. So the course is closing today, and so if you have not made up your mind, I would recommend that just buy it, and then if you don't like it, you can always get a refund. That is something you can do. Okay, we have the code. So the code is now shared. Chaco, about student discount, why don't you send me an email and we can talk about it. Officially, there is no discount, but we can have some payment plan kind of thing. So so what are the advantages of using sparse representation based face recognition? This is going to be a long answer. So I'll send me an email. I'll send you the answer. One of the people asked, is it possible to audit the course? So even if you audit the course, which means that you take the course, don't do the final project, yes, you can do that. You will not get a certificate in that case, and it does cost the same. Let's see if you have more questions. So from my perspective, the reason I'm so interested about the paid course is that it allows us to publish a lot of free content. If you think about it, it allows us to continue doing what we are doing on learnopencv.com, creating free courses, supporting it. It's something that it's our mission to actually spread AI to maximum number of people. But at the same time, it also allows us, the paid course allows us to sustain a small team. There is only, Harshal, there is only one project in the course. This is the final project. We do ask, sometimes we have this intermediate small assignment where there is a small prize. So for example, last time we had $100 prize for implementing something faster than what was provided in the course. So a particular transformation, if somebody had implemented, and people actually did better than what code we had written. And so, we have, sometimes we have those kinds of prizes, but those are not compulsory. The only thing that you need to do to obtain a certificate is the final project. So, so one of the questions is, I have an industrial application for OpenCV. How will the FACE course help me? Now, the FACE course, I don't know what the industrial application is. First of all, it teaches you a lot about how to use OpenCV in general, right? A lot of times we are stuck because OpenCV documentation looks very complex. It is very intimidating. You don't understand what's going on. When you take this course, you are exposed to so many different examples that you get a sense, you start feeling that, yes, OpenCV is some library that you can easily use. Then if your application actually involves, say, object detection, tracking, and those kinds of things, and there is a direct application. So hopefully that the course does not cover 3D face recognition. It uses 2D face recognition only. Yeah, so what is the difference between the articles in my blog and this course? So there is some overlap in the articles as well as the blog. The difference is, first of all, you will get support. The second thing is that it is a much smoother implementation. Like somebody was just asking that, how do we integrate dlib and OpenCV? In case of, say, face averaging and other examples we have shown, we do not integrate the two things. It becomes very complex to explain everything in a blog. But when we do it in a course, we do that integration. We show how you can do it right there. So that is one thing. And we also go in depth. For example, facial landmark detection. That's one example where you can look at the blog. You can actually use facial landmark detection based on what we have published in the blog. What you will not get is how to train your own facial landmark detector. What are the things that you need to be, you need to worry about. You won't get the code for landmark stabilization. So suppose you use it for an application like face swap, those things will jiggle a little bit, won't look very good. So, and then you will not know the underlying theory. So how does it actually work? What is the underlying theory? That you will not learn. So there is substantial difference between, the blog. Our objective is to get as many people started as possible. We are not trying to make experts on this blog. What we are trying to do in the course is trying to make you an expert. So that's the big difference between the blog and the course. Vikas can actually Oh, thanks, Michael. Thanks for registering. Vikas can give the course. If you have, look at the material inside the course. Also, we have forums, etc. And frankly, if it doesn't provide value to you, take it for 29 days. If you think that you are not getting enough value, in that case, I would highly recommend that you don't, you take a refund. It's an expensive course for people, and we understand that. So if it doesn't provide value, I want you to take a refund. It's perfectly fine. Thanks, Nikita. Thanks, Nikita, for registering. I'm looking at questions, trying to find which ones we have not answered. So one of the questions that Mattis asked is, he's very busy right now. Will the course be open for enrollment in future? So there are two things there. First of all, once you enroll for the course now, it is available to you forever. So you can actually complete the assignment, complete the final project within 1 year and still receive a certificate. And even after that, if you send us an email, we'll let you go beyond that time. The course will, I mean, we are not 100% certain, but there is a good chance that it will open for enrollment again in about 5-6 months. But the price may go up. So like when we started, the course was a certain price. This is the third time enrollment has been open, and every time the price has gone up. So yeah, so those are the disadvantages. And there is a small chance that this will not be a standalone course in the future. It will be part of a bigger course or something like that. So there is that small chance also. We have not decided yet. Oh, yeah. So Munish, he has a question that, is it necessary that the final project be done as a group? No, it is not necessary. In fact, most of the people had done it individually, but there were groups also in our course. Like you can have groups of 3 people. For voice related, everybody uses TensorFlow now. So the benefit, Avinash asks, for voice part, for speech related AI, what are the things people use? So the nice thing that has happened over the last few years is that these frameworks like TensorFlow is used by the text recognition people, as well as the speech people, as well as computer vision people. So there is a convergence of all these different tools, and now the tools are the same. So that's a good thing. Well, so door security system, Niranjan, yes, all those things are possible. It depends on how reliable you want the door security system to be. People do that all the time using Raspberry Pi and OpenCV. They create a security system. Yeah. So one of the questions is, I'm using dlib, but the alignment affects the recognition. So I want to know if it is possible to replace it with 3D alignment. So there is some code out there that semi 3D alignment. I cannot remember the URL right now, but I can, if you send me an email, I'll be happy to send that back. So many face, I'm sorry. So many face recognition algorithms these days use that as a pre-processing step. So yeah, it's possible to improve the results with better alignment. I'm trying to look for questions that we have not answered. There are a lot of questions. So we are hitting the 1 hour 15-minute mark. We are also hitting the time window for this enrollment. So Karam asked, is financial aid available for learners who cannot afford fee? We have a payment plan available. You can pay in 3 installments. Yes. Niranjan says, I cannot understand eigenfaces. Can you just say in 1 or 2 lines? Since I shared the code with you, I feel I'm obligated to answer that question. So what happens is, now think of a 200 by 200 image. It has grayscale image. So it has, so 200 by 200, 40,000 numbers. You can think of this image as a vector in a 40,000 dimensional space. Now, it's a big space, but it is possible to reduce the dimensionality of the space. You can find, so if you take many faces and perform principal component analysis on it, in that case, the first dimension, so principal component analysis will give you different dimensions. The first dimension will capture the direction of maximum variability. So what are the pixels, or what are the what are the things that are changing the most in all these images? So that would be the first principal component. The second principal component would be a space which is orthogonal to it, which is perpendicular to this previous space, and the maximum variability is there. So with eigenfaces are nothing but principal components when you do it on faces. So now what eigenfaces do, so you find these various vectors which are in which are directions of maximum variability, and you can take these vectors and combine them. So you take the mean image, combine these vectors in different ways, and these vectors are each called eigenfaces. So each vector is an eigenface. So you can combine them using some weight, and in the code that we just shared, that weight you can use and combine using the slider. You can pick a weight and combine it with a mean image to get a new image. So it's almost like this high dimensional space, which was completely arbitrary. These pixels could take any value. Now you have changed them to a much lower dimensional space. Like if you're using only 5 eigenfaces, then only 5 eigenfaces can be used to reasonably approximate any new face. So the face, imagine that a new face comes in, right? And suppose my face comes in, and my face was not used to produce the eigenvectors or eigenfaces. But you can find an approximation of my face using other people's face, and you'd be surprised how close it comes. We like to feel that we are all unique people, but when when you combine different people's faces using this eigenface concept, right? So you build these eigenfaces using some random people, right? They were not, I was not part of that structure, but you can use the right weights, and the face that it produces would be very similar to me. It would look like me. So that's what eigenfaces it gives you a small number of faces that you can combine with the mean face to produce any arbitrary face. Hopefully that makes sense. So Karam asks, my project is knowing the emotion of the person through the face. Yeah, so the best kinds of algorithms right now for this kind of problem is they are deep learning based. You essentially train a convolutional neural network with many examples of different emotions that you want to identify. So that's, use CNNs for this is all I can say. That's the short answer. Thanks, Sean. So one other question, are the code developed compatible with Raspberry Pi? There is nothing in the code which tells you that you cannot run it on Raspberry Pi, but we are not actively testing. So it is possible that some of the code would be very slow for Raspberry Pi, but there is nothing in the code as such that says that you cannot run it on Raspberry Pi. So can PCA solve the blind source separation problem? Is so you can use other things like ICA, independent component analysis, etc., for that when multiple people are talking and you don't know the sources, etc. Do you offer any deep learning courses? We do not yet offer any deep learning courses, but if you take this course, we provide an introduction. So 3 of the modules, out of the 12 modules, 3 modules will be deep learning based. So there would be an introduction to deep learning. We will use deep learning to solve face recognition and emotion recognition. So Andy, you can use the payment plan that we provide. Hopefully that helps lower the burden. Okay, guys, I think it is time to. Does Raspberry Pi support Keras? I've never tried it, but I suspect that it should be possible. I don't feel that it won't be possible. Definitely should be possible. I've never tried it myself, though. That's it, guys. I think thank you so much for joining this webinar. This is the first time I have done this scale webinar. We have done it, for our courses, which are usually the audience is smaller. Thank you so much for coming, and I really appreciate you coming here. So I have a hard deadline. I have to actually be in another meeting. So so I'll have to take leave now. But if you have any questions, please send me an email, It is S as in Sam, P as in Paul, Malik at learnopencv.com. So I'll try to answer as many as I can. And the registration window, the gift registration window, we will keep it open for another 8 minutes or so that it is 10:30 a.m. My time. So that should be good. That is it, guys. Thank you so much. I hope you got some value out of it. Thanks, guest 9003. I wish I knew your name. Thank you. Okay, guys. Thanks. Bye-bye. Thanks, Munish. Thanks, Sai. Thanks, Manal. Okay, bye.